Now that the cylinder heads are, excuse me, I've got the cylinder head mocked up with no gasket, and I have one set of lifters in, cams at the bottom of its base circle. This tool here, with a bushing in it for the two different size Chevrolet rocker studs, is for checking pushrod length. This is an adjustable pushrod that you drop down in there, and then you adjust it to length until it just touches the tool here. Then you can measure your pushrod to get the right length pushrods. Now it happens, probably not by chance, that these rockers are designed to fit the standard height GM retrofit. This will fit a standard height GM roller lifter. So in this case, I order the correct length push rods for that, which happens to be, in this case, I think it was 7.2 inches. And I went with Howard's push rods because I'm using Howard's lifters and Howard rockers, Howard lifters, Howard cam, keeping everything all Howard so everything should work together. And then you can, of course, put on the posi locks and test everything. So that will have, let me move the camera so you can see. Once these are adjusted, it's got the right ratio, and you can see that the roller fulcrum, focus. There we go. The roller is in the right spot on the valve tip. And of course you can adjust the lash here to get everything right. But before we can do the final install, and again, there's no gasket here, so there's going to be however much that gasket height is, and I can't remember off the top of my head. Don't quote me, it might be 10 thou. So there'll be a little bit of up here. Obviously that's over exaggerated. And we're using 1.6 rockers. Howard says that these rockers with these valves and these heads and this cam should all work. But to make sure, I have this very expensive no cost spared checking tool installed on top of this piston. This is definitely not Play-Doh. This is a very precise tool. And we're going to put this cylinder head on just loosely. I'm just going to finger tight the head bolts with no gasket. Excuse me. And I'm going to put a set of lifters, push rods, and rockers on this cylinder, and then rotate the engine around, take it apart, and see how much clearance there is. Now, again, with no gasket, it should be tighter than the running clearance, so it will be pretty tight, but it'll give us a good indication of how much piston to valve clearance there'll be. If there is a piston to valve clearance issue, the only options we have are to go back to a 1.5 rocker or a thicker head gasket to lift the head surface away, or we could fly cut the pistons, and I think we all understand that there's no way I'm going to go to the expense of having these pistons fly cut for more valve relief. This should all be fine. We're going to check it just to be sure. So let me get that set up and rotate through, and we'll go from there. Thank goodness that totally worked the first time, and I didn't have to do it multiple times. Pay no attention to any Play-Doh that might be in the ringlands. You didn't see any of that. All right. What we see here is the valves went down and touched, and if you pull this off, it's tight, but it didn't go through any place. Okay, so we can take this over here to the workbench, and then if we cut that in half carefully through both of the valve marks. Well, that didn't quite go straight, but you get the idea. Okay, so you can see it got thin, but there was still clearance on both of them. The tightest part is actually the piston to the cylinder head, and what I was concerned about is clearance to the valves. Okay, so that tells us that with no head gasket, we have sufficient clearance to the valve pockets with these pistons, which shouldn't be a surprise because if I rotated this up, this is not a zero deck engine. This piston will not be, well, let's see if I can rotate that with one hand. This is some excellent camera work. Went a little bit past dwell there, so let's see if we can rotate it backwards. Okay. So you can see there is clearance. The piston is not perfectly flat with the top of the deck. Okay. So since these combustion chambers are flat with the deck, nothing protrudes in, so the piston will not contact the bottom of the cylinder head. The valves don't hit the valve reliefs. We have some deck height clearance here. This may not come up to the 10.4 compression ratio that it's supposed to. I could CC this and measure it, but I'm just going to go with the advertised numbers and call this a 10.4 compression engine instead of worrying about it, because I'm not going to gain any more knowledge. This is not going to be a turbo motor. So the Play-Doh test, I mean the very expensive measuring tool test, tells us that we have clearance here, so we're good to go forward. The next thing we got to do is we got to get this timing cover to fit. And you see there's a gap there. That's because our timing button is a little bit too long. So I've got to figure out how to machine that timing button a little bit smaller, or whack that a little bit further out so that I can make clearance for that. There is a thrust spec on this camshaft and how much it's supposed to thrust backwards and forwards. So I got to check that. And I think I'm probably going to start by just smacking that with a hammer, sitting it over a piece of pipe or something, and using a socket extension or something to hit exactly in the center of that Y shape to give myself some clearance there. Instead of trying to machine this, this is crowned. You can see that that is not flat, and I don't have a lathe, so all I could do is chuck this into my drill press and try to shorten this, and I don't think I can do that with any accuracy. All right, which one of you noticed it? Why didn't you say anything? Why didn't you notice it? Okay. The crank gear pulley wasn't pushed, or crank gear wasn't pushed all the way in. So this was all pushed out, and the chain was what was hitting the timing cover. So now it fits gloriously. It's just right. And I checked for thrust, and the cam does wiggle back and forth, not an awful lot. So everything is now copacetic. I can go ahead and seal that with, I am going to use a little bit of RTV. Let me tell you how I do RTV. Wrong. That's how I do it. I'm going to put the bead of RTV, oh, there's grease on my fingernail, on this side of this little sealing ridge, all the way around on this side of the timing chain. And I'm going to use a very thin bead of RTV, okay? Now here I'm going to kind of go over that sealing ridge all the way around. So I'm on this side, the oil side of the seal. And then I'm going to go on the block and around like that. And I'm just going to put the absolute thinnest coat of RTV. Not a big goopy bead. Goopy bead is what you use here on the China wall, but just the thinnest wisp. Just to hold, basically you're just trying to tack this gasket in place. And the same on the timing cover. And yes, I've got to put the seal in. But the next thing I got to do is I got to put the seal in, and then I got to test fit the balancer. But just the tiniest little bead, little whiff. Okay, you don't want a big glop here. And the right stuff to use here is, say it with me, right stuff. Permatex right stuff is the stuff I like to use. The black stuff is going to work real good in here. And that'll have that sealed up. And then the gasket that goes here is going to be this one-piece gasket. And I will put just a little dollop of RTV in these corners here and down here just to make sure it seals, but nothing at all on this rail all the way around. This rubber you leave, or silicone, you leave that clean and it'll seal against this around and do everything. I've gone ahead and painted the water pump and the fuel pump block-off plate and the oil pan, which you can see I immediately scratched, so I've got to repaint it. And what surprised me the most was how close of a color match between cast aluminum spray paint and cast aluminum in real life I've got. So for $10 a can, I've made this into an all aluminum engine. Aren't you jealous? Yeah, right. Anyway, so the next thing is I'm going to put the seal in this and then test fit the balancer and then test fit this all again. And yes, I'm going to scuff, prime, and paint this Mylodon. I know the gold iridite finish is cool. It's very 80s. I don't like it. I'm going to paint it silver. So the whole engine is going to be silver. It'll all be silver. Everything silver. Everything silver. I got the windage tray test fit. So it clears the rotating assembly and it clears the oil pan. I've measured all of these lock nuts for the bottom side with the back side of a mic just for height. You can use a ruler or whatever. And they're all set the same height up. So I'm going to make a mark with a marker and turn these down 2 revolutions and then hit them with a little Loctite and turn them up 2 revolutions so that the Loctite is in the threads and the nuts are back in the same spot. Now I'm going to put the windage tray on, Loctite the top side, and Loctite the nuts on the other side so that these don't move up and down. If I ever get in here and I have to take this thing apart again, which, I mean, if I have to take this thing apart again, we probably need to go to an LS motor. I can always use some heat with a blowtorch or an impact on the top nut and enough leverage with a open-end wrench to get that off, or channel locks, whatever. I can get these nuts back off if I have to. To get here, if I have to take the bottom end back apart, but all these are already torqued. The bottom end's done. So I'm going to set those up. I got my oil pump screened to the right height. And there's some surface rust coming up in here, but it's been real humid here in South Carolina the past few days, and you can hear it raining right now. So it's just from the air. It's not, it's not like it's bad enough to worry with anything. You see, it's all just rubbing right off. So I'll probably go around and clean all that up, make sure all that rust is off. That's actually I think that's some grease, and that's a paint that was on that cap. So anyway, I'm going to do that, Loctite the windage tray in place, and then we're going to go ahead and put on the timing cover, and then I'm going to leave the oil pan off until I torque the heads, just because in case something horrible goes wrong and I drop something in the engine, I'd rather it drop straight through for right now or be able to fish it out than have to take the pan back off. So that's the next step. Everything is wiped down and degreased. Cylinder head gasket is in place. I've already looked up the part number to get the compressed thickness and double checked with the manufacturer. So this should still end up to be in the 10.3 to 10.4 compression ratio. So we should have no problems whatsoever with aluminum heads. Everything, like I said, I've wiped everything down. All my cylinder head bolts, I've got RTV liquid on it. I've wiped down the cylinder head. So I'll set it in place. Maybe like that. And you can see I put the liquid Teflon on all of the bolts. So the next thing is just to start screwing all of these in, which is not very exciting to watch. And then these are ARP bolts, and they're the bolt kit that is called out for specifically to work with these heads according to AFR. I guess it's got something to do with the head bolt length or something, I don't know. But it's the ones they spec, so that's what I'm going to use. And of course, being ARP, they come with their own torque spec and settings on their sheet. I'm not going to recite it to you because I haven't memorized it, number one. Number two, a good friend of mine, Kevin Cooper, once told me to never memorize a torque spec. You should always have to look it up. That's what he learned in the military, apparently. I'm not saying that's the right thing to do either, military and all. But he said never to memorize a torque spec. I always look it up. So I'm going to look up the torque spec that it calls for and do the torque spec and pattern that it says on the instruction sheet, and in the GM service manual, make sure that the pattern matches up, which shouldn't be a problem. I noticed that two of these head bolts are different heights. I don't remember if that's the same on all small block Chevrolets or not, but whatever. So before I do that, I think I am going to go ahead and take these guide plates off just so I've got a little bit more room to get in there with a torque wrench. But got to get all these torqued down to the right spec. Come back when that's done. I'm going to go ahead and do the other side the same way, and then we can move forward. Cylinder heads are now torqued in place with the gasket in. Remember, when you're installing cylinder heads, check the factory service manual, and you want to make sure you're using the right pattern around. And I had the service manual right beside me when I was doing it. In this case, they're torqued to three steps. These bolts spec 70 foot-pounds of torque, so that's what I torqued them to. Don't anticipate there'll be any problems with that. Used the ARP lubricant between the washer and the head of the bolt like it said to, and I used some Permatex liquid RTV on the threads. These plates are still loose because I've got to soak the rockers and put the push rods and everything in so I can get these guide plates aligned up correctly. There's some slack in there, as you can see, to get everything to line up. I went ahead and put on the fuel pump and the fuel pump push rod. I used a lightweight push rod with a bronze tip against the cam, which is probably overkill, but I don't care. Timing covers on, RTV on both sides of the gasket, a little thin smear. It's kind of messy, but I'll live with it. Timing pointer's on. I marked 0 on it with black ink so it would be easier to see. I am going to clear coat this engine once it's assembled. Balancer's on. This is a Summit brand balancer. It was a balancer with a crank bolt and flex plate and bolt assembly kit. When you put on a balancer, don't just drive it on. Use the right tool. This tool screws in and you hold this in with the wrench, and the big nut you turn and that pushes it on slowly. It comes with a spacer. I have a bearing that fits flat against the balancer on one end, and then I put the spacer on the bearing, let it turn so it's a little easier to turn and drive in more smoothly. That's a trick from my friend James. In fact, this is probably a tool that he might have given me. So the next thing is I'm going to put the oil pan on, and then it'll be the lifter and rocker assemblies. Again, this cylinder head's done. I haven't put the plugs in for the water jackets here because I want to check the engine in the car to see about header clearance, because the pipe plugs I've got two kinds. This flush one that's steel and this brass one that won't corrode as much, but it's got the square head. So as you can see, well, it's easy to do when you're holding a camera in one hand. So when this is tightened up, that's pipe thread, so it's tapered. This is going to protrude, so I want to make sure I have enough room for the headers. Otherwise, I'll have to use these. And the problem with using these is I don't have a square drive that fits that, so I'm going to have to go get one. Not the end of the world. I can probably figure that out. Also, you see one bolt this cheap eBay stainless steel kit was missing one header stud, so I'm going to stick a bolt there. Just so I remember that I've got one. I might have to put it in a different location. Next step is to finish buttoning up the bottom end of the engine, which means fitting the windage tray, the oil pump, the pan, and the oil pump pickup. All of this was harder than it had to be. This is a high volume oil pump, and of course windage tray. This block didn't come with a windage tray, but that's why we put the studs in for a windage tray. I had to cut a lot of this windage tray. Back out this bolt. This windage tray went basically like this, and I cut this whole corner off to clear the oil pump, and it does clear, especially if you put the pump on the studs correctly. So I had to make sure that this windage tray wasn't touching the oil pump. Then I also had to make sure that the height of the windage tray was set so that the connecting rod, bolts, the heads, and the counterweights didn't hit the windage tray. The way this is installed, you can see that there's a nut on the bottom and a nut on the top, and you raise and lower the pair to get this to the right height. So it's all set, and I measured the height of each nut so that it's flat. Once I had it cut to clear, of course I beveled all the edges so that nothing was sharp, cleaned all the burrs off everything, all of the slag. Got this height set. Then I had to make sure that when the pan was installed, first of all I had to make sure that it would clear with this stud kit, that the pan wasn't hitting the tray. So I ended up having to lower the windage tray and then raise it, lower it so that nothing was hitting anything. Now I've got the oil pan to fit. It obviously has to be painted. Next trick is this has to be inserted into here and welded in place so that there's a 1/2 inch of clearance between the pickup and the bottom of the pan. And the way I'm going to do that is tapping this in place and then getting it level, and then putting a straight edge on it and measuring down to the pan rail. And then I'll measure from the pan rail to the bottom of the sump in the oil pan and do the math between the two so that the pickup is between 3/8 and a 1/2 inch from the bottom of the pan. You don't want it to touch the bottom of the pan. You don't want it all the way up, and you don't want it tilted down so that so the pickup isn't submerged in the oil. You always want the pickup to stay submerged in the oil. Now, obviously, since that just moved around, the cover is not installed on this oil pump because, like everything else, I've gone and deburred all the edges and cleaned up all the passages so that oil will flow as freely. Also, this particular one has the bypass spring in the cover instead of in the body, which is nice because when I put this in place and get my final height set, I can tack weld this pickup to the body so it won't vibrate out. I had bought one of these clamp kits to clamp it in place, and that would have worked good, except it doesn't seem to fit with this high volume, and it's also not for the large diameter pickup tube, so it doesn't fit because this is a big diameter, and so this won't fit. So I'm just going to throw this in my spare parts since I can't return it, and it was not very expensive. I'm sure I'll build another small block one day. And then the other thing is, since I'm going with a high volume, I have to use a hardened oil pump drive shaft, and it says in the instructions to make sure that you get one that has a pinned sleeve so that it will stay engaged on the drive on the bottom of the pump, because you don't want it to walk out. So this will stay engaged on the drive, which is of course sitting on the bench because I've got this disassembled. Because once I get this tack welded, I'm going to clean everything real good before I final assemble it, tighten up these little bolts, and get everything, put the gasket in place, and torque the mounting bolt to the right spec. And then we can put the oil pan on for the last time. I chose to go with studs here instead of bolts, just because I got a whole stainless steel stud kit from eBay for not much money. And mostly I wanted the stud kit for the exhaust headers. Okay, I have set the gasket in place so we can account for that as well. So we're just going to put a straight edge, which in this case is just another steel ruler, and I've got 2 steel rulers just so I have a straight edge. So our finished height is 7 9/16. 7 9/16 inches, including the gasket height. So really, after that gasket's compressed a little bit, it's probably 7 1/2. But 7 9/16 is what this measures. So now we have to go over to the block and do the same thing. Okay, I have installed the pickup screen, and the way I did it was I used a crow's foot wrench on a 3/8 extension and drove it on with that. So I've got it down seated. Now you can see I've got a straight edge across it. I've got it installed. It's not torqued, but it's tight. And since we were at 7 9/16, we want 7 3/16 to have 3/8 inch gap. And if I sit it there, I hope y'all can read it, but it's 7 3/16, and that's not the first try. It took several tries to tweak it. Now what I'm going to do is I'm going to fire up the welder, and I'm going to burn probably 2 spot welds on this just to keep it from rotating and vibrating back out. And then I can clean all this. And you see there's a little bit of flash rust in there. I'm going to take Scotch-Brite to it just to clean that up. Clean all this, reassemble the top, torque it down, and this will be ready to install. I like my grandfather's ancient scale. It's an engineering scale. It's got 4 different measurements on it. I never use it for anything but a straight edge. Ironically, I keep using this cheap one. I should probably use that. Anyway, I don't even remember where I left off with the last clip because it's been a couple days. That's kind of the way this has been going. These rockers require guide plates, and we've got the right push rods, guide plates, and the rocker studs came with cylinder heads, so I know all that'll match. I did check with Howard's and with AFR to make sure the 1.6 rockers will work. If they don't, we'll just have to buy 1.5s. So what I have read online is you want a little bit of wiggle there between the push rod and the guide plate. Now you can see that one's completely loose because I haven't got it tight yet. So what I've been doing, and it might be wrong, is putting on the rocker, getting the rocker squared over the valve, making sure there's a little bit of, not a lot, but a little bit of side-to-side play. See, now that one's not square. These are. They're probably the camera messing with things. And then I go back and tighten the stud to lock the guide plate so that the push rod has just a little side to side. Now it's going to go up and down, but it has to as it goes through its travel. So you want just a little side play to make sure that it's not touching the guide plate. These are hardened push rods, so it shouldn't wear them out, but you know, you don't want to add any problems. You also want to make sure that the rockers are centered over the valve stem. You can do that by putting a magic marker or Dicam on there and rotating it through after these are lashed, to make sure that it's somewhat centered. But we've already got a fixed push rod, so we're going to go with what we got. And we can loosen or tighten the lash a little bit as we need to, but not an awful lot. Now, you can see these lifters are at the bottom of the travel. You can see this one's going up, and this one's going up. Now, lashing the lifters is easiest done with the intake off, so you can see what's going on. So these, you've got the lifters at the base circle of the camshaft. So you can adjust the rockers. And these being Chevrolets, you run the posi lock down until it touches, and then give it a half a turn, and then lock the Allen nut in the back of the posi lock to lock it in place. You can see I haven't adjusted this side yet. I got a lot of work to do over here. So what I'm going to do is go through and make sure all these are lined up. And again, the camera angle is messing things up, but these aren't, you know, the rockers are up too. So I'm just trying to get things centered. So it's hard to tell, but that is centered over that without the camera in place. I can tell that that is centered. They're also purple. I know they look blue, but whatever. So once I have it centered, you tighten this nut and it should be locked. And you want to still, again, make sure you've got that side-to-side travel just a little bit. I think it's like 50 thou total, so it's like 25 per side or less. Maybe I'm wrong on that, but and then I'll lash all this stuff. And I haven't found like whether or not to use Loctite on these, but going into aluminum, I'm not going to. I'd rather have these back off and have to retighten them than have to take these off sometime in the future and pull the threads out of the head. I know neither of those are good, but I think an emergency side of the road repair with having to tighten up a rocker arm stand is better than having to redo these cylinder heads if I have to get back in here again. So I'm going to go through and tighten all these and lash all these rockers, and I'm going to do it with all of them on the base circle, and then I'm just going to rotate the engine, and while they're all down on base circle, instead of doing it by the timing marks, you can do that. It's in the service book how to do it. And then once they're all lashed, then the next thing to do will be take the intake manifold off the other engine. I have bought one of these Summit HEI rebuild kit. It comes with cap with coil, plug retainer, rotor, vacuum advance, weight kit, fancy tool for installing stuff, different springs. If you look at the back of the instructions, it has different timing curves. Kind of don't know what this engine's going to do, so I'm going to start off with the middle because I don't know why not. This is a GM distributor HEI that I took out of that crate motor. As you can see, I've already started taking it apart. The factory control module and wiring. Maybe you can see why I'm replacing this part. The new part comes with a condenser already attached, but it's a different kind. I think it'll be all right. This is the new module. It's supposed to be performance, who knows. And a new wiring harness, which is the key to this. I've already taken off the distributor gear. That's a little seal retainer at the bottom. And I had problems with one of the screws for the vacuum advance, so I'm going to have to see if there's a new one in the kit or if I have to replace it. So I'm taking the shaft out because you can see down in there I've got to clean all those shavings out from drilling out that screw. I used a left-hand drill bit, so once it started to bite, it just backed right out. Left-hand drill bits are invaluable. You should definitely get a pair of those. Also, I'm going to, down here at the very bottom, all the work I put into oil control on this engine, I'm going to put just a small cut, not through this side, but through this side up part way, maybe 3/4, 7/8, whatever, with just a hacksaw blade to cut just a thin sliver right there, which will divert some of the oil from here to the distributor gear, help keep this lubed. Now, distributor gears are annoying. This is the one that was on this one. It's just a regular cast iron, regular steel gear, whatever. I talked to Howard Cams and asked which gear I needed for the camshaft. You have to match the gear material to the camshaft. And they said that I can use one of these cast ones. The other two, well, there's 3 other options. The common option is a bronze gear you would use with a billet core camshaft. They do tend to wear out, and I really didn't want to end up with that, but if that's what Howard said to run, that's what I would run. The other option is a melanite gear. They're not this black color, they're kind of a gray mottled color, and they're kind of expensive. They're $70 to $100, whoever you buy from, whatever. Prices vary, shop the internet. And then there's also a composite gear you can buy out there that's supposed to be the best of both worlds. Since Howard says I can run this gear, this is what I'm going to run. If you don't know, if you have an unknown cam, you don't know if it's cast or billet core, the safe bet is melanite. Melanite will work with either a billet or a cast core cam with no problems. It's more expensive, but which is easier? Replacing a gear for $70 to $100, whatever it costs, or tearing down your engine because you wiped out the distributor gear drive on your camshaft. So Howard says I'm okay with this one, so that's what I'm going to run. If they had said to use bronze or melanite, that's what I would run. If you don't know, melanite is a safe option. Bronze is a safe option, but bronze is going to wear out. The problem with bronze on a street car is that these teeth will wear down to the point they just wear off, and then you don't have any timing. And that's kind of an issue. So anyway, I'm going to take this shaft out. I'm going to take this Hall effect sensor magnet off and clean all the shavings out of here real good. This wiring is still good, so we're going to keep it. Clean all this real good. Like I said, I'm going to cut that just a little slice part way through. I think the internet said something like 30 thou, whatever. I'm just going to use a hacksaw just to get a little cut. I'm not going deep and I'm not going all the way through. I just want to divert a little bit of oil to this gear to help keep this gear lubed. Is it going to hurt anything? No. Is it going to help anything? Probably not. So whatever. Clean this up, and then I'm just going to follow the directions on reassembly. Comes with new weights. That's the blue spring kit. That's what I'm going to use. Comes with some hardware. That's the silver spring kit. Another silver spring kit that's heavier. And then vacuum advance. This is an adjustable vacuum advance. You can tell because it's hexed instead of round. So you can stick, in fact, that's probably what this Allen key is for, is to stick down in there and adjust your vacuum advance rate. So we're just going to baseline this with the middle timing chart and see how it performs. I'm not dyno testing this engine, so I'm never going to get it perfect, but I just want to get it better. So I'm going to get this all cleaned out, swap up all the parts, and then we will put the distributor on the engine, and we'll start making spark plug wires. We got them; these are cut to fit spark plug wires, so we got to crimp the right ends on it. So I'm going to make these, get the spark plugs in the engine, and then take all that back out and use my special tool, which is a cut down distributor, to pre-lube the engine, and then install the intake manifold, and we'll go from there. All right, we've had a momentary crisis. These are angle plug heads. These are the headers that came off of my wife's father's 70s dirt track race car. They're not designed for angle plug heads. So numbers 2 and 3, or numbers 3 and 6 spark plugs. No, 1, 2, 3, 4. I can't count today. That's kind of day I'm having. Numbers 3 and 4 hit the tubes. So now that I've sandblasted and painted these headers and have them looking just, I mean, those look great. I've got to heat them up and bash them to make clearance for the spark plug or replace the headers. And a can of spray paint's $20, and a set of headers is probably several hundred. So you know what we're going to do. All right, these are cut to fit plug wires. The drill with this is you take your longest plug wire to make your longest run. So we're going to take this one and stick it on the spark plug. Doesn't necessarily have to be snapped in. And then you're going to route it around neatly. And this is 1, so we want to make sure that it will go to the number 1 boot. And you want to leave some slack. You don't want it to be super tight. You can do these go right over the top. You can route them however you want. You can route it around like that. Whatever. Make yourself happy. I'm going to route these up like this so that I can take some spark plug wire separators and zip ties and everything else I can come up with. I'm going to probably reuse the spark plug wire separators off the old engine because I haven't bought any others yet. They're red, but they'll work. And I'm just going to route this around, eyeball it about like that. So I'm going to cut it, skin the wire back, fold the conductor over, and then I've got a mandrel. I'll show you that in a second on how to put the ends on. So step 1, get your length the way you want it. So I'm going to cut this one. I'm going to route it so it's nice and neat up to number 1 on the cap. And then I'm going to give about an inch to strip. And we're committed on that one. Focus. Maybe. All right. First you want to put your boot on. You take that conductor and you fold it back. And then you take the terminal and you slip that over so that it's pinched back. And then you will crimp the terminal onto that. I can get it started here with these wire cutters. So you're going to crimp that back. First you got to get this on, which is a real joy in itself. So I'm going to put some lubricant in there and push this on, and we're going to go to the vise and I'll show you how to get this on. Okay, you see I've got the boot on, I've got the conductor stripped back, and I've got the terminal. I'm going to take these pliers and just start that crimp. I've got my thumb detector. We're going to need a thumb detector. Then it sits on that end of the mandrel, and this one's cut so that it will crimp that connector shut on the wire. Now it's a little bit of finagling to hold everything so it's all lined up. You want that die to push right down the middle of that crimp. And a couple passes with this set up. This is an old set of dies, and it's not as good as the kind that are like a pair of wire pliers or cutters, but this old method will work. You see it's kind of slow, kind of fiddly, but get a little more tight in there, more tight in there. I'm just locking that into the insulation. See, we've got good contact there. So once I pull this boot back over, You want to make sure that this is the HEI end style. You want to make sure that the boot is lined up so that the terminal is in the right angle in your boot. And there, took a little bit of doing, but the terminal is down in there. It's a little twisted. There, it's straight now. And that's got an HEI end on the wire. Point style ends are the same procedure, but it's a different shape. And every kit I've used, the HEI ends are silver and the point style distributor cap ends are brass. I don't know why that is. Maybe, I don't know. So now I got one wire ready to go. And if we come back over to the motor, test fit, get that locked in, route this wire around, and get that on the plug. And then with some looms, zip ties, whatever you want to do, you can route that around. You see I got a little bit of extra so that I can adjust my timing. I mean, nobody's adjusting it that much because that's where we need to be. That's number one, pointing here at number one. So we're going to do the same thing for the other 7 going around the order. Again, taking the closest connection wire all the way around. And I'm probably going to try to loom them as I go so I make sure that I have everything neat and I want them to be generally about the same length. Fiddly, time consuming. This will probably it's going to take me a lot longer than it should. But we will get all the wires done. And then we have this harness set aside and I can address this problem with this header pipe. Like I said, my choices are, I messed up. All right. Thank you for mentioning that. That would have been a problem. Anybody want to take any wages on how much oil gets on the shop floor? I'm guessing a lot. The purpose of this is not so much to see how much pressure we're building. This is just to make sure that we have oil through the bearings and everything. Well, we're getting bubbles up here in the lifter valley. Ooh, drill struggling. Getting oil up here. Try a new battery. A real drill instead of a cordless drill would probably be better for this. Yep, that ain't gonna make enough torque. But try again. All right, that should make enough torque. Oh yeah. We are getting oil to the top end, as I can see the rockers filling up. Rotate the engine a little bit. Oil dripping, oil dripping. These rockers are down. We're on our marks. We're going to spin it just a little bit longer. I think we're done here. The chuck is slipping on this distributor shaft. It's not keyed, it's just slick. And there's an awful lot of pressure down there in that thing. That high volume, high pressure pump putting a good load on this thing. That shaft, not cold. But we did get oil out of all 16 rockers. It's in the head. You can see this green oil pooled up. It's down here in the bottom end. So we did get it all the way through the engine, which was the main goal, just to make sure that we had oil pre-lubed up to the top end. All the rockers down in where the posi locks are, there's oil pooled up in those. Well, it's starting to run out now, but there was oil pooled up in there. So the next thing is going to be, we're going to set the intake manifold. We can take our, not cold, take our test distributor out here, which again is just a gutted old HEI. I have no idea what I took this out of, but it was out of a Chevrolet, obviously. And we're going to use a good bead of RTV on the two China walls and around the water ports front and rear. These have sealant around the air ports, so it shouldn't need any RTV there. We just want to get it around these water ports to make sure they seal. And the China wall. Some people have luck with the rubber inserts on the China wall. I don't. I'm going to bring you back over to the workbench and we're going to talk about the intake manifold. Alright, this is the intake manifold we're going to use. This place is kind of a mess. What else is new? This is a Jegs in-house copy of Edelbrock Performer RPM non-air gap intake manifold. I'm using this because I have it. The right intake would be a regular Performer RPM air gap. I've seen tests with this intake versus the RPM. They're pretty similar. I'm probably leaving some horsepower on the table. I have this. It's paid for. It was on the 305. It was too much for that. I've got another intake to go on that. I did the same thing with the intake as I did with the heads. I put the gaskets in place, and if they were lined up. Well, I put the gasket in place, again, upside down. There we go. Hell, I put the gasket in place, and then I used some Dicam. You can use a Sharpie, and I marked this whole surface, put this in place, and then I took a scribe and traced it, and then I opened up all these ports with the sanding drums, just like it did on the cylinder heads. So this is ready to go on. I do not have the water ports filled up because I haven't decided if I'm going to use the ports in the radiator, and I don't have the water neck on because the one that was on it is pretty scuzzy looking, and I either need to paint it or replace it. So I'm going to go ahead and RTV, gasket, set the intake. I'm going to see how that goes. It's starting to rain. Alright, I've got bead of RTV. I've got water around the water, or RTV around the water passages. I've got the gasket stuck in place. We're going to see if we can do one nice clean drop. Like that. It's pretty good. I'm going to put a few bolts in to get everything centered up. Looks like I'm actually a little bit forward. And then I'm going to come back, and since all of these bolts go into the lifter valley, I'm going to put that Permatex liquid Teflon on all of these bolts, just to make sure that they don't weep oil up and out onto the intake manifold that I did make an effort to get scrubbed up nice and clean. And these are socket headed, so they're Allen style intake manifold bolts that came in that kit. I was just trying to get something in stainless, and I know stainless into aluminum cylinder heads isn't a great idea without anti-seize, but right now I'm just trying to get everything centered, and then I'll come back and put the liquid Teflon on, and that will act like an anti-seize to keep these from galling in the cylinder heads when I tighten them up. All right, so got them all in place. I've got a good squish on my RTV around the china wall, a little bit of mess here to clean up, good squish in the back, so I'd say that's successful. So now all I got to do is put this Teflon on each of the bolts and seal them in. These center ones are going to be a real joy. I'm going to have to probably cut down an Allen wrench to get them to clear this tall plenum. I think this side's better, but this side, the plenum's bigger on this side, so I think this side's going to be a real challenge. And then we can move forward to whatever's next. So, okay, I'm going to clear coat the engine with header clear coat, keep it looking good. I'm going to address the headers and the spark plugs. But first, I need to see what kind of valve covers we're going to run on this. These were selected by my wife. They're pretty serious valve covers. Proform slant cast aluminum valve covers. I think they look pretty sick. You can kind of see where I'm going with this. The carburetor has yet to be rebuilt. I got to get a new thermostat housing like we talked about. I'm working on deciding what I'm going to do here. So the point is to keep everything sealed up as nice as possible for as long as possible. I really don't care about the oil filter, but it's on there. So I want to clear coat the oil pan, seal these heads, seal these valve covers, and to go with all that awesomeness, pull this out of the box behind me here. I have the matching cast aluminum air cleaner, which, you know, obviously goes up on a carburetor, but I think that's going to look pretty sick with the cast aluminum. I've got a breather to go in there too, so I'm going to clear coat all this stuff so it all stays nice. Try to keep as much grease off it as possible, as long as possible. So now you can kind of see why I painted this stuff in pieces. The paint's going to flake off of this chrome fuel pump. Who cares? It's probably not going to stay on anything very long, but I just want it to look as good as possible for as long as possible. We're at the point right now where all we've got left to do is clear coat this and put it in the car, and then I can get all the other stuff decided. So I'm going to go ahead and clear coat that. I bought a set of solid motor mounts. I've got to change the frame mounts because this uses clamshell style. And I put those on, they're 15 years old and they're already broken. So we're going to solid mounts. So I got some grade 8 hardware, lock nuts. These are painted silver. Of course, these will fit, that's upside down. Those will fit like that. And then sit down in the frame. So we'll have all this silver in that black engine bay Again, I got to deal with the carburetor. So right now I'm just going to put spray a coat of clear on all this.